Okay, so you can see in the last video we kind of talked about, a continuous graph, and what that really means is that it really means a whole lot of infinite points in between two values, or that could go on forever, but it's more than what we could just write down. Remember that in the relations video where we talked about a set of ordered pairs, we were able to list exactly the x values that were a part of that graph. But in this case, because we could have potentially an infinite number of points, we can't list those individually. So we have to learn how to list a domain and a range in a range style. And I don't like to use the word range here because of this, but it is a range of numbers that we're going to be using for our domain and range. And so the way to do that is up here. I've already started up my notes for you so that you can have that. I'm going to go ahead and fill that in. So when we're looking for domain, those are x values, so that's the horizontal direction. So we take a pencil, okay, so here's my pencil, and we lay it down, and we start scanning left to right, okay, left and right, and we look for a place where there is a point on our graph that touches our pencil left to right. And in this case, every single point is going to touch. And then there are these arrows here, this arrow and this arrow, which means these lines continue out forever, left and right. And so what we realize quickly here is that every possible x value you can imagine is going to be a part of this graph. So it's going to be one of those situations that we talked about in our cheat sheet called all real numbers. Okay, and we write that in interval notation from negative infinity to positive infinity. And remember, infinity symbols always have parentheses with them. Okay, and so I'm just going to be doing this in interval notation because I know it's the newest to you, and then that way you'll have a chance to kind of get to know that and get used to it, and kind of just get comfortable with the interval notation. If you would like to see it written in inequality symbols, you can ask for that as well, and I'll be glad to send you examples of what that looks like. And so you can check your work to see if you got it correct. Okay. So now we're going to do the same thing with the range, except for with a range, we're going to go top to bottom. So I'm going to pick up my pencil, and remembering that these keep going up and out forever. I know that I have points here, and everywhere that I'm touching I have points, I have points, I have points, and then there gets to a place, and that place is right here, where below this there is nothing left as a part of that graph that my pencil is touching. So what that means is that my y values are only from this point up. Okay, and so the y point here is -2. So from -2 up to the positive infinity direction, I have a range that's a part of this graph, but I don't have any numbers below that. So that means my range is going to go from bottom to top. So from bottom, my bottom point is -2. Okay, and -2 is part of that graph. All right, it is not an open circle, it's actually a point on the graph, so we use a bracket, and we go from -2 to infinity. We're going to a positive infinity up in that positive direction, and we use a parentheses with the infinity. Okay, so that's how you would write that as a range. Okay, and so I know that this is going to take you some time to get used to. We're going to do several more examples of this just so that you have an idea of what this looks like. But I do want to show you very quickly before I move to the next one. You do have another cheat sheet. It's actually a flow chart that you can use to help you on this. And I've already included that in your notes as well so that you have access to it. So let me pull my copy out so that I can show it to you so that we can kind of walk through this. Okay, so we're going to use this flow chart on question 3 so that we have a chance to talk about it. Okay, all right, so this says domain for continuous relations. Okay, this is continuous. It is a line, and all the points are connected, and we're looking for domain. So look at your graph. Will it keep going to the left forever? Okay, so let's look to the left. Is there an arrow that keeps going forever? Yes. Okay, so let me slide this over just a smidge so that you can see it all at once. Maybe we can get that included. Here we go. All right, so this, now you can see, here's number 3. And here is our flow chart. So will it keep going to the left forever? Yes, it will. Okay, so we come to yes. Look at your graph. Will it keep going to the right forever? So if I keep going this direction, all the way to the right, here's my arrow. Will it keep going to the right forever? Yes. Okay, so look at my pencil. All the way to the left, all the way to the right, it's all touching and it's going to keep going. So yes, it goes to the right forever. So then in that case, the domain is all real numbers. And so we write it as that negative infinity to the positive infinity, and we use parentheses, okay? So then we start talking about the range. So I'm just going to fold my flow chart over here so I can look at it. Okay, so range, this is the direction here that we have. We're going to go look at your graph. Will it keep going down forever? Okay, well, it's currently going down. Even though it's at a slow pace, it is still going down, and it's going to keep going down forever. So yes. And then look at your graph. Will it keep going up forever? So same thing. It is going up, and it does have an arrow, so it's going to keep going up forever. So yes. So in this case, the range is also all real numbers from negative infinity to positive infinity. Okay? And so don't stress yet. We are going to do several more examples together, and then I'll give you a chance to work on some on your own.